Welcome to the 7th lesson of Quality Management course, the Enterprise Quality Metrics. In the previous lesson, we talked about quality management and the importance of metrics in monitoring and control control of business and quality performance. In this lesson, we are going to focus on enterprise quality metrics and key performance indicators. We'll also try to provide answers to the following questions. How do we measure quality? What are enterprise quality metrics? What are systems, products, and process key performance indicators? What measurement tools we can use to monitor and report on these metrics? Metrics and KPIs, or key performance indicators. Metrics provide quantitative information on products, systems, or processes. They can be used for controlling the development process and for historical data analysis. Quality models are mechanisms to define a consistent and useful metrics program. For example, the ISO 9126 specifications. There are three terms to understand related to metrics and KPIs. Measures, which is a discrete number. For example, the number of unique website visitors, or the dollars sold, or euros sold, or the defects per unit measure. Measures can also be absolute numbers or ratios. The second term you need to understand is the dimensions, which provide context to your measurement. Dimensions can be time, product, territory, or geography, etc. The third term is metrics itself, and those are what we measure. There are also three KPIs, or key performance indicators. There is system KPI, there are system KPIs, there are product KPIs, and process KPIs. Let's take a look at the quality management system key performance indicators. There are 7 key performance indicators for a quality management system within an organization. So how do you know how well is your management system is performing? You know that by comparing the following 7 metrics between the time before the implementation and the time after the implementation of the quality management system, or from year to year and quarter to quarter. So the first key performance indicator is the customer complaints. Did the customer complaints increase or decrease? Did you identify new complaints? Did you resolve old complaints, and so on? Other complaints include staff complaints, internal. If you remember, in the beginning of the course, we explained that quality is not only about customer satisfaction, but also about stakeholder satisfaction, and stakeholders means they are the customers, staff, suppliers, partners, and investors. Another indication of performance of your quality management system is the reduced, and of course, we are talking, if you remember, we are talking about enterprise quality management rather than just a process management or manufacturing process management. So within the context of enterprise management system, one way to measure the value of your quality management system is the number of reduced employee turnover. The fourth metric, or the fourth KPI, is the productivity. And the way you measure productivity is by comparing the current number of, for example, number of dollars produced per department or per a profit center or an organization divided to the ratio of, or to the number of employees within that organization or profit center. And of course, comparing it to competition, comparing it to your previous state before the implementation of quality management system. The fifth KPI is the customer satisfaction index. And customer satisfaction index is is the result of surveying customers on their satisfaction on rate, say from 1 to 5 or 1 to 10. And then you average that and you basically create an index to know that, for example, the number of customers satisfied is 80. 80% of the customers you service are satisfied with your products and services. Customer loyalty index, and this provides indication not only to the satisfaction of the customer, but also this will let you know through the survey if they are gonna, if they did, or through historical data, or if they are gonna buy new products and services from you. So that's also an indication of the superiority of your products and services compared to your competition. Another important enterprise quality management KPI is the revenues and the profits. Did your revenues increase? Did your profits increase? Of course, if you had a properly implemented quality management system, you will reduce waste, you will improve efficiency and effectiveness, and therefore you save the cost of your operation and increase your profits. As for revenues, you will increase your revenues through enhanced customer satisfaction and the resultant sales increase due to word of mouth. The second type of KPIs is the product KPIs. And metrics should be defined on the basis of the most relevant properties of the specified product being developed. For example, if it is software, it could be portability, maintainability, efficiency, reliability, requirement, processing requirement, and so on, or code complexity, etc. If it is a car, then probably speed or horsepower is a metric that you are looking at. The size of the engine or the size of the seating is another metric. The price, the selling price compared to your competitors is another metric or KPI. The third metric or the third KPI is reliability. And a very useful industry measurement unit is what we call MTBF, or mean time between failures. Mean time between failures tells you how many years or how many months before the product that you bought would actually fail. So the longer the MTBF or the bigger the MTBF value, the more reliable is your product. Maintainability. Another measurement unit for maintainability is the MTTR, and that is mean time to repair. That tells you basically how long does it take once the product fails, how long does it take to repair it. And this is really a function more of the design of the product. If it is modular, easier to replace, it's easy to replace the parts, or if it is very complex and it takes several days. So that's also another metric that you would use to measure the performance, the quality performance of your product. And of course, we have the cost of the product, and with cost, not only the production cost, but also the cost to the customer. And the difference between the price and the cost is that sometimes you might buy a cheaper car, but because it is less reliable, the total cost of ownership on maintenance over the years tends to be much higher than buying a more expensive but reliable car that doesn't require as much maintenance. This graph illustrates the cost of poor quality and provide information on the interaction of two key performance indicators, the time and cost. From this graph, we can see that an earlier detection of errors, an earlier detection and correction of errors, of course, is far more cost-effective than later one. If you remember at the beginning of this course, I mentioned the example of Firestone and Ford Motor, and how much did it cost them to, in hundreds of millions of dollars, to correct defective products. This happened actually at the customer stage after the product has been sold and resulted in death. Now, they could have saved much more if they had a quality control process that detected the defect during the manufacturing process or during the testing process, and they would have even saved more cost if they had quality control at the design phase with proper verification of engineering specification. That, of course, would result in saving on scrap, pre-works, etc. We discussed the cost of poor quality, but there is also cost associated with good quality. The cost is the cost of the quality consultants you're going to use to introduce the quality management initiative to your organization. The cost of internal resources available to work on the quality management course, on the quality management initiative. The certification application fee if you are planning to certify with a third party, an independent third party like an ISO 9000 registrar. The cost of quality assessments. The cost of maintenance of the quality management system. Surveillance visits. And of course, the cost of the documentation. Now, the third type of KPIs is the process KPIs. And a sample of process KPIs is or key performance indicators include the efforts or workload. You will be measuring the reduced workload. This can be measured using historical data or the actual efforts against estimated efforts, process time saving by speeding up the production process or time to market, or response time to the customer, or by reducing errors and defects, or by detecting early the number of early detection of errors in the system. What tools we can use to measure quality metrics? We are going to cover in the next few slides several tools. The first one and the most common is the survey tool. And the survey tool rates your satisfaction or the customer satisfaction from, say, 1 to 5 or 1 to 10, with the lower number or 1 being the poorest of satisfaction and 10 being the highest or 5 being the highest. The survey tools normally address product satisfaction, service satisfaction, and also whether you're going to buy from us, therefore providing information for the customer loyalty index. Also, it not only you can also measure through whether the customer is really excited about your product and thinks that it is of good value enough to recommend it to his or her friends and associates. You can provide an open-ended question for them to give you feedback on specific issues and problems they faced, whether it's an issue they faced with an individual or an issue they faced with a system, or a product for that matter. Also, you can ask for improvement, and probably your number one asset or your number one research and development source and your number one innovation source is probably your customer, because they use your products extensively and therefore they know more about it and about its limitations within their environment, and their feedback is very valuable for you to improve your design process and improve your design specification. Another tool is the risk rating tool. For a process, this tool can be applied for a process, a product, or a service. And it is represented by three colors: the green, yellow, and red. With green being okay or meeting stated requirement and needs. Yellow meeting partial needs of the clients or partial stated requirements, and red is default in performance or non-existence of quality procedure to ensure meeting the standards. We can apply the green, yellow, and red risk assessment tool to supplier risk rating. And this can be used to measure 9 criteria for supplier assessment. The first one is CAR issued. And CAR stands for Corrective Action Request. How did your supplier respond to your request? How soon and how well? External audit findings. Did ISO 9000 independent registrar or independent auditor find non-conformity, and what did the supplier do about them? Do the supplier have a self-governance program? How they handle hardware non-conformances? Do they have a software process, and on what level they operate? Do they operate on the capability maturity level of 2 or 4 or 5, and so on? How does their design and development system match up to your standards and to your quality requirement? How well they share with you and report on test defects, failures, and failures? Are the delivery data documents of the supplier adequate enough? Has enough details about their products or their material? How is the management effectiveness when you escalate an issue to them? Do management take active responsibility and work on resolving the issue? These are all important criteria in evaluating the quality of your suppliers, and therefore in ensuring the quality of your products. This slide shows an example of benchmarking for General Motors. The benchmarking allows a company to compare their performance to best in class in the industry. For example, if you take a look at the number of labor hours per vehicle for General Motors, tends to be 30. For the best in class, the number of hours spent on a car is 19, and the leader in that sector is Ford. The number of defects per vehicle is 3.1 for General Motors, while for best in class it's 1 defect, and the leader in that category is Toyota. And so on. You can benchmark your performance, your quality performance in all the aspects of your products. You can benchmark your quality performance on all the aspects of your products, your services, system, processes, and so on. Reliability. A product will be functional. Reliability is defined as that a product will be functional when used. Actually, the reliability is a function. Reliability of a complete product is a function of its subsystems. For example, if we have a Walkman or an iPod or an electronic listening device, the reliability of the entire system depends on the reliability of individual components, like its electronics, controls, and headset. One very useful tool in identifying quick wins and identifying most problematic areas within a manufacturing process is the checklist. In this slide, we have an example of a checklist for a textile manufacturing process that produces shirts. We take a look at the types of defects available in shirts per, say, 1,000. And we find that there are 4 out of 1,000 produced shirts. There are 4 defects in tiers or defects in fabric, either in tiers or discolored. We find that the most defects are having loose button on the shirt, and sometimes we find ragged edges. So one way to use this tool is to identify where best you can have a quick win, or what we call the lowest hanging fruit, is to try to address the most problematic area that produce maximum saving and efficiency. So ideally you would start by reviewing the process of tying the button to the shirt. Once we discover that the shirts actually, the loose buttons are the most problematic area to the quality of producing a shirt, the next step is to identify when does it happen or where does it happen. So one way is to use bar charts to map the number of loose buttons per shift. And in this example, we find that the average number of loose buttons per, say, 100,000 is 20 through shift 1 and shift 2. For shift 3. And shift 3, we find that in shift 2, there is more than average in contributing to the defects in having a loose button, which will focus your attention on the system working in the shift number 2. If it is people, then probably they require more training. If it is machines, then it probably require maintenance, and so on. Root cause analysis. Now, after we have identified that it's in shift 2, of course, we will use what's called the CE diagram or cause-effect diagram, sometimes called root cause analysis. And you would look at the possible or potential causes for having a loose button. It could be people, material, it could be process. Example of issues that you might face is wrong setup, machine speed, too much speed, or machine maintenance. It could be people require training, too much absentees in shift number 2, or improper communication between various workers. It could be the materials that are being used are out of specifications, or other issues like environmental issues like humidity or schedule changes. Measurement and calibration. The most important objectives for calibration of equipments is the ensuring of the accuracy, precision, and resolution of the test equipments or measurement equipments. Another tool for measuring quality is statistical techniques. Statistical techniques involves two concepts, statistical process control and acceptance sampling. Statistical quality control or process control was initially the application of statistical techniques to acceptance sampling pioneered by Dodge and Romig of Bell Labs. The purpose was to avoid the cost of 100% lot inspection while lowering the customer risk to receive defective products and the manufacturer risk to reject good ones. Let's take a look at the statistical tool application. In this diagram, you will look at the normal distribution or variations in quality between the statistical numbers of -3 sigma to +3 sigma. You'll see that the natural process variability graph, that the process variations can occur due to several causes like temperature variations, clearances, distortions, measurement errors, etc. When each cause is held to its practical minimum, the resultant process variability is called natural and follows a normal distribution as explained a few seconds ago. Detecting assignable causes. Assignable causes are variations above the minimum. They can be detected by periodic sampling of the process and plotting data such to prevent time history. Such to preserve time history in order of the production sequence. We spoke about Six Sigma. But again, we are using it here as a statistical tool. So sigma is a statistical unit of measure that reflects process capability. The sigma scale of measure is perfectly correlated to such characteristics as defects per million or parts per million, defectives, and the probability of failure or error. Sigma of 2 results in 308,000 defects per million, while a sigma of 6 results in only 3.4 defects per million. The goal of any process or a system is to achieve, of course, a value of a sigma that's equal to 6. Here's a practical example that shows the implication or the impact in the variation and the importance of the number of sigma. A sigma of 3.8 will result in the loss of 20,000 male per hour, while a sigma of number 6 or integer 6 result in 7 male lost per hour. The same thing, if you have a sigma of 3.8, it means you can have 7 hours with no electricity for almost each month, while if you have 6 sigma value in your process, you will go with 1 hour without electricity every 34 years. This takes us to enterprise quality metrics. Again, what are the enterprise performance metrics. Is the company meeting its goals, its monthly, quarterly, and annual goals? What are the business key performance indicators? How can we track them? What actionable steps should be taken to reach those goals? I'd like to share with you an insight by Albert Einstein. Not everything that can be counted counts, and not everything that counts can be counted. The traditional business performance has always been based on accounting standards, where you only measure the cost, you measure the revenues and the profit. Although those are very important and critical key performance indicators, but they are not enough to measure the performance of the organization. In the next few slides, we're going to explain why. Some of the business performance metrics includes the finance, and you can measure the performance of the finance function or financial life cycle through the capital raised, the interest rate of the capital, the interest rate of the capital borrowed, the price per earning ratio, the debt to equity ratio, expenses, profit, return on investment, return on capital, and equity. Intangible metrics. There are intangible but very important metrics that provide information on the performance of your business within a certain time period. In 1982, the tangible book value, that's the tangible assets that you have, including the fixed assets and the cash in the bank, represented only 62 of the company market value. So if a company is worth $100 million in a public market, the actual assets of that company was actually only 62%. In 1992, after 10 years, this value even dropped to 38%. So if the value of the company is 100 million, then the actual assets of the company is 38 million. In 2004, it is estimated to be 25%. So that shows that there are other ways of measuring the performance or the value of the business, not only through money. The non-financial metrics that is considered in the valuation of the company includes the quality of the strategy, the management credibility, innovativeness, the number of new products they produce, the talent they have on their team, their market positions, if they are number 1 or number 2 in certain target segment, the quality of measure processes, the quality of their research, and other performance metrics. Other performance metrics to measure the enterprise business performance is in the area of supply chain management include the cost of your products, just-in-time parameters, the shipping and delivery times, as well as the supplier service level agreements. Just a reminder that although we mentioned what SLA means, or supplier service level agreements means that if you contact your supplier for a problem, how much time does they take to respond to you? That's one. The second element of a service level agreement is if once they know about the problem, how long does it take for them to resolve it? For production life cycle or production department, the performance metrics include defects, quality index, and machine time. For human resources, metrics include productivity, employee turnover, and employee satisfaction index. For R&D, the number of new products and services improvement, the number of patents filed. For customer relationship management, the customer loyalty index, the increase in sales, number of new customers acquired, and the customer service level agreement, return on advertising spend, the response, the resolution time for customer issues. Let's recap what we have learned in this lesson. We defined we learned how to measure quality. We learned what are quality metrics for a product, for a service, for a product, for a process, and for a system. We listed key performance indicators and for quality as well as for the enterprise performance as a whole. We covered the available tools for you to measure quality. Those include surveys, checklists, and vendor rating. We covered cause and effect diagram, benchmarking, charts, and statistical techniques. For more information on enterprise quality metrics, you could refer to International Institute of Management, iim-edu.org. With this slide, we come to the completion of this course. For more information on the lesson and for more exercises and a reference to textbooks, you may refer to UNINETTUNO website and click on MedNetU project.